Welcome. I'm Greg Horstmeyer. I'm editor-in-chief at DTN. I manage the digital newsroom in Omaha, Nebraska. Welcome to this year's DTN Ag Summit, our first virtual summit. Appreciate everyone being here today. We just heard from Dr. Ranveer Chandra of Microsoft, who's talked to us about where we are in terms of data science and data decision tools and using data to make decisions in agriculture. He sort of brought in that 35,000 feet level of what some of the big picture things that Microsoft is working on and some of the projects they're working on with various companies. What we're going to do now with this panel is get down to the field level. And so I'm really pleased. We have three panelists with us today who are using data every day to help farmers make decisions. And so we're going to talk a little bit about some of the things that we've got going on. We'll start with introduce Dr. Jyothi Shankar, who comes to us from Indigo Ag. Dr. Shankar runs a team of a number of scientists who are working around the regenerative agriculture area and sustainable agriculture area. She'll talk to us a bit about some projects that Indigo has in that world. We also have James Hannigan, who's Senior Vice President for Gro Intelligence. Those of you who are frequent readers of DTN might recognize James' name. We work with Gro in our annual digital yield tour that we do. So we use Gro's data there. Third, coming to us today is John Muse, who's Chief Scientist here at DTN in our Clear Ag unit, who's working to build some decision tools that farmers are using to make decisions. And DTN purchased Clear Ag a little bit earlier this year, just as COVID was hitting. So been an interesting year. Dr. Shankar, I'll start with you. Talk to us a little bit about your team, and then talk to us about this rice project that you had with Anheuser-Busch, and how you use data to bring some farmers into that.
Firstly, thank you, Greg, for having me. It's a pleasure to be here and talking with you about one of my favorite projects ever. So my team, as you rightly pointed out, is a bunch of scientists, data scientists, sales folks on the ground, field scientists who are looking at practices, and also partners in Anheuser-Busch who are deeply thinking about sustainability. And together, what we are doing is we are bringing the missions of two of our companies together and seeing how we could just make it really easy for farmers to understand how is it that they get premiums for the grain they grow, and what does it take for a corporate organization such as Anheuser-Busch, which is also the biggest rice buyer in the domestic rice industry, to get that rice on time for their mill. They use it for their lagers, have it be sustainably grown, and connect with the farmers to give them premiums. So we are the party that brings them together, and we are just embodying our mission. How do we help farmers harness nature to sustainably feed this planet? In this case, it's bigger, but we have several such collaborations with large organizations thinking about how do we hit corporate sustainability goals and also come closer to farmers and enable them to do it. So this team is very multidisciplinary because you have to have folks speaking with farmers and explaining the financial implications of changing practices that enables them to be more water conserving, greenhouse gas reducing, and really explain to them the impact of what they are doing on the grain they grow and convey to Anheuser-Busch. And then you've got to have people talking to Anheuser-Busch on how do we kind of plug into what they need as metrics to say that this rice was very sustainably grown. And then you need all our analysts and engineering teams and all of the other data folks to really run on the hamster mill, trying to get data and build the models and internally just massage everything together, run analysis and some of the biogeochemical models on it to estimate methane, and put it all together into one series of unending reports that gives Anheuser-Busch the visibility into what's going on in each of the 29 or 30 farmers, 15,000 acres in Arkansas, which are enrolled in this project. So that's a very 40,000 feet view of what we do and kind of the complexity of this project and all the threads that need to come together on time across the season that make this possible.
Appreciate that. We'll shift now to James. Talk to us a bit about, tell us a bit about Gro's modeling work and the digital and satellite imagery pieces that you put together. But also, one of the issues that's been going on is, USDA's monthly WASDE reports and in the data that USDA pulls together is sort of the standard that the industry uses to look at supply and demand and to think about their purchasing decisions if you're a food company or sales decisions if you're a farmer. Talk to us a bit about where the models that companies like Gro are in that process and how they're being used every day by some of these companies and by farmers.
Sure. And thanks for having me, Greg. It's great to be on. I'm Jim Hennigan. I'm from Gro Intelligence. We're a global agricultural data and analytics company. And like Greg mentioned, we do a lot of work on global production modeling. A lot of it's satellite-based machine learning modeling on global agricultural production. We model out area, yield, production for many, many crop country pairs globally. Specifically in the US, we focus on models that predict area, yield, and production for US corn, US soybeans, US hard red winter wheat, and we do a lot of other crops and country pairs with the same machine learning based approach driven by satellite inputs. And we provide those outputs down at a very granular level. So they can be used for on-farm prediction. They can be used for district or county level estimates to benchmark if you're a farmer in a particular area and you want to benchmark versus your county. You can do that. We provide state level estimates, national level estimates, and then global predictions so that there's usefulness from the farm gate all the way up to the global basis for what might be produced in a particular area or aggregated up to a larger regional area. The satellite models, how they're being used, and they can be used for, on-farm assessments, how a crop's progressing through the year. They could be used by anyone in the supply chain from the farm gate on up, originators, co-ops that are buying grain going into a particular area to supply, whoever might be in the supply chain downstream, be it feeders or processors or food companies. We work with physical traders, that are trying to get a handle on, the absolute supply, whether it's up or down, and should they be buying or selling based on that information. And we look at that. And so a lot of these satellite-based yield models are being employed, all the way through the chain. So farmers that can look at it, on farm for their crop health, or originators trying to say, we have more in our area to buy or hedge against than we did last year. Or traders in between, physical traders, or even financial traders, some traders that are just trading the financial markets, looking for predictive signals to speculate on futures markets that are out there, and they use them as well. So it really runs the gamut. And then, beyond that, not only just traders, but people trying to understand what's going on in the space and an assessment of it. It's USDA agencies that are using these models to have a better handle beyond their survey methods that are out there. So like you mentioned, Greg, in WASDE reports, historically they've done a lot of survey work, but now they employ a lot more of the satellite-based information to help them buttress their estimates. So they're doing good work both on the ground and then using the satellites down to come up with their crop estimates every month and things like WASDE reports. So satellite-based yield models. Different types of, new advanced modeling techniques for area, yield, production. They're being employed, and they're being employed by lots of different participants along the agricultural supply chain.
Great. Thank you, James. John, returning to you now, tell us a bit about your team and what you guys are working on, and also about sort of the challenge and the effort that's going on to bring all this disparate data. We're desperate for data, but all this disparate data into the models that companies like DTN and others need to help farmers make decisions. Tell us about what you're up to.
Thanks, Greg. As chief scientist at DTN, but also actively farming with my brother, I maybe bring a little bit of a unique perspective on things. As a farmer, I guess we've made some pretty significant investments in tech, in equipment, in both being able to capture data and hopefully turn that data around to improve our operation. Definitely feel the pain of keeping that technology working, and the frustration that it's still quite difficult to turn that data around to the benefit of our operation. As a scientist, I see the enormous amount of potential that there is in that data. It's really interesting what you can see going on in your fields if you really dig into it. We can gain a better understanding of our own fields and operations, but we can also, as a community, by pooling that data, there's a lot we can learn from that data that you can't learn from data from one farm alone. And so, as a scientist, I'd like to see the data more freely flowing to get maximum benefit of it. So we need a better balance, I think, with more reliable, foolproof technologies for collecting the data, more and better tools to allow farmers to reap the benefits of that data for their own farms, and better mechanisms for pooling that data and gaining insights from it. So now, at DTN, we have a long history, obviously, of providing information to the ag industry. We may have been a little bit slow in pivoting to support the new, high-tech world of farming these days, but we're working to aggressively change that and building an ecosystem of interconnected tools that will support farmers' decisions throughout the year, aiming to ease some of those pain points that I discussed previously, and begin allowing farmers to reap more immediate and tangible value from those pretty significant investments that farmers are making in equipment and sensing technologies. So we aim to automate data flows, use and reuse that data again and again in various ways. And so a few different ways that we're doing this. Maybe starting with pooled applications of data, we've developed algorithms where we can take say planting data for a particular hybrid from multiple farms in multiple locations over multiple years, and harvest data, just the harvest date and the harvest moisture content. And we have algorithms we can use to automatically, using machine learning, to develop a crop growth model and a crop dry down model for a particular variety, so that you can then in follow-on years, or when that model is deployed, we can automatically tell you what stage of growth your crop is in at a given time, so that you can time out, say, herbicide applications or whatnot. We can tell you, when your crop's going to reach maturity, how quickly it's going to dry down thereafter. All that by just by pooling data and applying machine learning to it. On a more personalized level, I guess I have some frustration that it's still surprisingly difficult to really manage fields at a subfield level, to get down into management zones, that can be infinitely small, really. It's frustrating how difficult that is to do at this day and age. We've been collecting this data for a while now. So right now, those management zones are often created without the benefit of the data the farmer has collected over time. Oftentimes it is based on satellite or whatnot. We also have problems that a single set of zones is not really ideal at all, because you may want a different set of zones for planting, for nutrient applications, crop protection, irrigation. And so we're developing algorithms to dig into your data over time for your different fields, and look at how different areas of the fields vary together, so that you can kind of tailor or get zones that reflect the very fine scale of granularity of your field and how those different areas vary together. Speaking from personal experience, with increasing farm sizes come increasing logistical challenges. You've got a lot of labor to deploy. You want them scheduled to be there at the right times to meet your needs, but not paying people to sit around and wait for the weather to cooperate. You want to optimize where and when your equipment is deployed, so it's not sitting idle when it doesn't need to be. And so we've been developing technologies to bring together weather data, soil models, and your machine data to learn patterns in when historically you've been able to work in different fields, given different combinations of conditions, and use that information, apply machine learning to it to predict going forward at a very fine granularity exactly when and where fields will be at a condition that is fit for performing a particular operation. There's all kinds of follow-on applications that we are eyeing within DTN. So, for example, we can feed your planting data into those crop growth models that are developed using the pooled data, and we can track where your field is at in its growth progression throughout the season without you needing to drive around the countryside to look at your fields on a regular basis, which can be very time consuming these days. Then we can use that growth profile of that crop to make assumptions about the crop's water and nutrient needs and where the root system of the crop is drawing from at any given time. And then automatically feed that information about the crop growth, its properties, the previous crop that was grown in the field, any nutrient applications to date. We can use that to model the sufficiency of your nutrient profile for your yield goals and whatnot, and provide you tools to optimize fertilizer applications. Similarly, we can use it to, say, model the crop's water use and where it's drawing from, and make irrigation recommendations that are tailored to your needs and system specs. And so there's just sort of an endless amount of things that can be done. So it's a really exciting time, I think, to be in this space. There's a lot of blue sky possibilities here, but we've got to get through some near-term obstacles to allow that to come to fruition.
John, we've got time for a few questions. I will slip back to Dr. Shankar. Jyoti, one of the things that you talked about getting together this group of farmers in the rice project, and you're working with other farmers and other projects. As somebody from outside of agriculture who's working to try to marry farmers with companies that are looking for specific kinds of products, what do you think the biggest challenge is for the farmers that you're working with? Is it having the right practices that create the, for example, the carbon footprint or whatever the criteria are? Is it having those practices in hand, or is it having the data around those practices? What of those two things, what do you think is the sort of the common thing that a farmer needs to change?
So the very cool thing about farming in Arkansas region, rice farmers, they are very plugged into what a sustainable practice can look like. And there's USA Rice, which is a very big kind of lobbying institution that brings all the companies that use rice together with the producers together. So they have done a lot of work in establishing what does a good stewardship of land look like if you're farming rice. So I think that several of our farmers are not foreigners to just implementing and embracing these practices that may be difficult to do on their farms. What is difficult about and challenging about bringing the scale of a project together is these practices are not easy. They require you to do a simple thing of just driving around the countryside, as John pointed out, and looking at your fields, turning off the wells at a particular point in the season, putting a dry down so that methane emissions are kind of reduced. And all of this takes effort and time and energy on the part of the farmers. So the challenging part is helping them understand what are the returns to doing such an intensive farming practice. And while that might not seem like a challenging thing on the surface, winning the trust of farmers and helping them understand what is the consequence of taking this tiny effort to do, it's not a tiny effort on their part. It may look like tiny from outside. So what is that return? So that is challenging. I think the other part of the challenge is, of course, that if one or two farmers, they're alone doing this and trying to sell rice to Anheuser-Busch and having them certified as sustainable, they of course need to do everything that John has talked about: collect data, aggregate it, bring it together into a usable format then run analysis on it, understand what's going on into creating the water, nitrogen, and methane metrics. That's not challenging for something like Indigo has set up, but it is challenging for the farmers. And so by convincing them that we can do that hard work for them, and additionally bring them together with a corporate partner who will view these results as a kind of verified good data set that they can apply against their corporate goals, that's what we are enabling. But the challenge is still, so my biggest challenge at this point, as I see it, is how do we get the entire Arkansas region farming sustainably, believing in what they do, and also getting paid the premium by not just Anheuser-Busch, but maybe Walmart, maybe the exporters to South America, maybe everyone who's the downstream user of rice, recognizing the hard work that grows into, that actually goes into growing rice differently, and rewarding the farmers for that, like holding them in pride. That is the mission, and that's perhaps the most biggest challenge that we are slowly moving towards. Someday we'll get there.
Interesting. Yeah, the totality of it all is the challenge. Very, very interesting. James, a question that comes up often in regards to crop modeling and yield modeling specifically is accuracy. And we've been working with you guys for a couple of years on the yield tour. And, my experience has been we're getting, and not you guys, but even other companies are getting within a bushel or so of the accuracy in August and September of what ends up being the actual yields that USDA certifies come January when they do their final yield numbers. Where do you think we are in terms of that accuracy? Do we have what we need there, and now it's just a matter of perfecting how we use this information, or is there still, with some of the odd years we're having and climate change and some of those issues going on, are we still learning to be more accurate?
Yeah, I think we're still learning, Greg. And as you noted, we've had a few odd years here, 2 years in a row. 2019 is a major flood year in the U.S., and then 2020, some odd weather occurrences like the derecho that ripped through Iowa and into Illinois, and to a lesser extent, Indiana. The frequency of these odd weather events seems to be more frequent than maybe we would be expecting. And now this year you throw in a pretty significant La Nina event, which will have its impact on crops globally. And I think the accuracy is going to be hard to stay on, and make good, accurate predictions to final yield estimates or final area or final production estimates by year end. I think the satellite yield models that are out there are quite good. They have good accuracy, mostly in the U.S. for spring row crops starting in August through to final. Error rates, different models, different companies, ours included. Call it 4% error rate at that period of time to final, and then it narrows into even down to 1%, come November to final, and a good couple months earlier than the government puts out their estimates. So that's valuable. I think the big trick is, how do you move that, and it's not August and it's now July. And as John just explained, and Jyoti as well, this is not that simple. Trying to model out crop progression for different soil and soil moisture characteristics and GDDs and progressions of plants at the farm level on up to a district or county or state or national level, and then come up with a national yield estimate, the benchmark versus the USDA, which is then doing their objective surveys and yet satellite yield models. That's not that simple to do that much earlier in the season with so much weather and climate at play. So yeah, that's the goal, is to try to get it earlier and more accurately. I would say, I wouldn't be too hopeful, but I think, getting to something that's at least acceptable or giving you the right direction, and that you're not directionally out of touch. I think that's some of the issue that farmers face, or cooperatives face, or traders face, is that when you have tools that are out there and you're looking to government agencies and government estimates to give you a guide. They want to see that the guide is accurate, and at least in direction early in the season, and then narrow into the error rates to final. So if the direction is flip-flopping all the time, then they lose confidence, and then they get frustrated with it. And I think the government agencies know this as well. I mean, I think that's what they're trying to do, is to try to get directionally more accurate earlier, and then narrow in the error rates. So there's still a lot of work to do, but I think it's way better. I mean, in my career in ag, I've been looking at this for a long time now, versus what you were able to do on a piece of paper and a crop tour out on the ground. And now, like we're doing on a digital crop tour from the air down, you're much clearer on crop potential early in the season with error rates. So it's very good. I mean, we've made a lot of progress, but there's still plenty of progress to go.
Thank you. This issue of how early can we begin to know what's going on around there. And John, that kind of gets to some of the work that you were talking about, farmers making decisions earlier and earlier in the crop year, trying to decide what the right thing to do. Part of that, though, John, in the work that you're doing is having data and having access to enough data. Dr. Shanker mentioned, she used the T word, trust, and talked a little bit about that. Later today, we've got a presentation by David Horsager, one of our main speakers, who's going to talk a little bit about using trust in to build your business. As both a farmer and a scientist, one of the issues around decision tools and around the things that we're talking about here is trust in who has your data and what they're doing with it. So with your foot in both of those furrows as a farmer who's creating data and worries where it might end up, but and also a data scientist who's trying to gather as much data as they can and pool that, as you said, where do you think we are in that trust area with the farmers that you work with in terms of feeling confident about what they're doing with their data?
Yeah, well, not near as far along as I would have hoped we'd have been by this point in time. As farmer, one thing I would say is to keep in mind is that your data are doing no good if they're just sitting on the shelf. There's a lot of potential in that data, but it's got to get out into people's hands to be able to turn it around and find value in it. So you really have to ask yourself as a farmer what you really have to lose by sharing it versus what you have to gain. At the same time, as an industry, I think we need to continue working toward standards and APIs and tools that make it easier to share this data, maybe ways of sharing the data in mass without having to give explicit permission to every type of company or scientist that might want to use your data in a pooled sense without having to bother the farmer to, allow that kind of an application. You should be able to just say, I'm okay with sharing my data for these types of purposes and just let it go at that. We also need to continue defining the ground rules as to how the data can be used and not abused as an industry, I think, in enforcing those ground rules. It is a little bit difficult type of data to anonymize. That seems like it's the easy answer, but environment matters in agriculture. The field characteristics matter. The weather that the field was exposed to matter. And so it's a little bit more difficult to anonymize some other types of data. But as a scientist, I think we need to share what we learn, freely share what we learn from these data so that it benefits all of us. There's just so much potential in this data, but it often can only be unlocked when viewed in mass. And so we need to do all we can to promote that sharing.
Well said. Well, thank you, all three of you, for this sort of look into where we are today and some of the successes that we're having. As one of you said earlier, this is a process that we've been, data decision and data driving tools is something that we've been working on for quite a while, and it's great to see some of the advances and some of the real world examples that we've got here today. I want to also thank everybody that is in our audience. I appreciate you participating in this. I hope you're finding this Virtual Ag Summit valuable. We've got a number of sessions coming up. I mentioned David Horsager and others today and for the rest of the summit. So please enjoy it, be safe, and we'll talk soon.